Hello everyone. In the video today we will be doing a free response question about analyzing the graph of the derivative. Alright, this is a big one, but we're just going to take it one piece at a time. So we're going to start with part A. So the figure above shows the graph of f prime, the derivative of the function f on the closed interval -1 to 5. The graph of f prime has horizontal tangent lines at x equals 1 and x equals 3. The function f is twice differentiable, which also means it's continuous, with f of 2 equals 6. So part A, find the x-coordinate of each of the points of inflection of the graph of f and give a reason for your answer. Okay, so point of inflection means that the second derivative is 0 and it changes sign from positive to negative. The derivative is increasing to decreasing or decreasing to increasing. So this means second derivative is 0. That means the derivative of the first derivative is 0. But we know another way to say derivative is slopes of the tangent line. So if we start with the second derivative is 0, it means that the derivative of the derivative is 0, but we'll change one of the derivatives to mean slope of the tangent lines. So the slope of the tangent lines of the graph of the derivative is 0, and that means the graph of f prime has horizontal tangent lines. And they actually already told us where those were, but if they didn't tell us, we could find them. At x equals 1, we have a horizontal tangent line, and x equals 3, we have a horizontal tangent line. So at x equals 1 and x equals 3, that's where we get the points of inflection, because the graph of f prime changes from increasing to decreasing in x equals 1 and changes from decreasing to increasing in x equals 3. So it's not enough to make the number line and say it's positive and negative. We need to actually say that it's increasing and decreasing, decreasing and increasing. It has to be changing. So again, they say at x equals 1 because it changes from increasing to decreasing. And then at x equals 3, it changes from decreasing to increasing. And we get 2 points for part A, 1 for the two x values, and another point for the reason. This reason where we talk about changing from increasing to decreasing, and vice versa. Alright, part B. At what value of x does f attain its absolute minimum value on the closed interval 1 to 5? And at what value of x does f attain its absolute maximum value on the closed interval 1 to 5, -1 to 5? Show the analysis that leads to your answers. Okay, so this is the most challenging part of this problem, but all of these words really boil down to what is the absolute minimum and the absolute maximum. So when we look for absolute min or max, we need to test both the bounds, -1 and 5, and any critical points, which is where the derivative is equal to 0 or where the derivative is undefined. But it won't be undefined anywhere because it's a differentiable function, which means it's also continuous. But the derivative set equal to 0. That's what we do when we find critical points. That means when we're looking at the graph of f prime, we're looking where the graph crosses the x-axis. That's where the derivative f prime is equal to 0, where the y value, where the output is 0. So everywhere it's 0 would be x equals 1 and x equals 4. Let's put those on the number line, but first let's put the boundaries, -1 and 5. Then let's put our x equals 1 and x equals 4. And if we take a look at our graph, everything above the x-axis will be positive. It means the derivative will be positive, and everything below will be negative. And again, everything that touches the x-axis will be 0. So if we look between x equals -1 and +1, we're below the x-axis, so it's negative. 1 to 4, we're still below the x-axis, so we're still negative. And then 4 to 5, we are above the x-axis, so we're positive. So look at this x equals 4. That's the only place where we change signs. At x equals 1, we don't change signs. We just stay negative. But at x equals 4, we go from decreasing to increasing, which means we have an absolute minimum. So we can say this mathematically by saying the function f decreases from x equals -1 to x equals 4. We know that with the number line. Then increases from x equals 4 to x equals 5. Therefore, the absolute minimum value for f is at x equals 4. Now, notice that the number line does not give any maximum value. It should still have a maximum value because we're on a closed interval. So the extreme value theorem says that if we're on a closed interval and our function is continuous, then we have to have both an absolute minimum and an absolute maximum. The number line doesn't give it to us, so that means it has to be one of the endpoints, -1 or -5. So we don't have a function to plug into, and whenever that happens, when you're looking for an absolute min or max and you're like, wait a second, we don't have a function we can plug into, and our number line doesn't help us, we can apply the fundamental theorem of calculus. So we can say the integral from -1 to 5 of our derivative function would be the function evaluated at 5 minus the function evaluated at -1. And notice for a second, just take a look at the graph. Most of the graph is below the x-axis, which means when we look at the integral part, we know the integral means area under the curve, and anything below the x-axis will be negative. So if most of the area under the curve is below the x-axis, then we'll get a negative answer for the integral. So the integral from -1 to 5 of our function, the area under this curve, will be negative, less than 0. Well, that means f of 5 minus f of -1 is also negative. And if we move this to the other side, it means that our f of 5 is less than f of -1. And that makes sense. To get a negative number when you're subtracting, this first number should be smaller than the second number. So if f of -1 is bigger than f of 5, means x equals -1 is our maximum value, absolute maximum. So this problem, this part of the problem, part B, is pretty crazy. There's a lot of points we can get. First, we indicate f decreases and increases. That gives us the minimum value. Then we say that we have a minimum value at x equals 4. Those two kind of go together. It's hard to have one without the other. Then we eliminate x equals 5 for a maximum and declare absolute maximum at x equals -1. Now, even if you forget the whole fundamental theorem of calculus thing, you'll still get points for saying that it's either x equals -1 or x equals 5. And if you just take a shot in the dark, you have a 50% chance of getting the point. So this is the meat of the problem. All 4 points are challenging to get, but we should aim to get all 4 points. Finally, part C. Oops, forgot to put that away. But anyway, let g be the function defined by g of x is equal to x times f of x. Find an equation for the line tangent to the graph of g at x equals 2. And this is just a reminder that f of 2 equals 6. That was in the very first part of the problem. So this is our general form of a tangent line. Y minus g of a equals g prime of a times x minus a. Well, we know a is 2 because x is equal to 2, so we can substitute that. And now we have to figure out what is g of 2 and what is g prime of 2. So g of 2 is easy enough. It's 2 times f of 2 by the function g of x. So f of 2 is 6. They gave it to us. So really quickly we get g of 2 is equal to 12. G prime of x we need to do a little bit more. Since it's x times f of x, it's a product, we'll do product rule. We do first times derivative of the second plus the second times derivative of the first. We get x f prime of x plus f of x. Substitute 2 everywhere. And f prime of 2, well, we have the graph of f prime, so we can look at x equals 2 and go to the output, and we get -1. So 2 times -1 is -2, plus 6 is 4. We have everything we can substitute. So y minus 12 equals 4 times x minus 2. And we can add the 12 if we want. We don't need to the other side. So notice that this problem is 3 points. And 2 of the points are just for figuring out the derivative. And I want you to really pay attention to that. Because you might forget the line of the tangent line. We've done a lot of them, but you might forget it. But knowing your derivatives is so important. This is like an easy product rule that you could get 2 easy points with it. And this is like the official scoring where they show getting the derivative, substituting, and then finding g of 2. That's all the work that they show. We showed way more work. But this is the work that they showed, and they have the tangent line there. And again, 2 whole points, 2/3 of the problem is just for the derivative. Not even substituting, just the derivative. Okay, That is it for this problem. See you next time for another free response question.